So you're studying for the SAT Math Level 2 subject test. You've come to the right place. I'm Dan from WeWillTeachYouMath.com. Guys, when you're using these videos to study, make sure you pause the video at the beginning when the problem first comes on the screen and try it on your own. Most of your practice should be done this way, actively and independently. Then, if after you try the problem on your own, you still find it tricky, that's when you watch the video explanation. In fact, you can use any resources that you have available to you to try to figure it out so that the next time a similar problem comes your way, you'll be ready. Enjoy, and thanks for watching.
37. F of x is this piecewise function where it equals 3x squared minus 3 over x minus 1 when x is not 1. So basically it's defined everywhere except at x equals 1. Because that would make the denominator 0 and it would be undefined. So it isn't defined there. Instead, it's defined as k, some value, when x is 1. So what that basically means is that everywhere, for all values of x except 1, this function has been defined. But at x equals 1, it's still being defined, but instead of using this function, they're just using some number k. And then their question is, what value would k have to take on for f to be a continuous function? In other words, if the function were defined at x equals 1 based on this function, where would k be? What would k have to be to make that true? It might be worth graphing to just get a picture of it, but probably the way to go is to kind of expand on what's in here. So we have 3x squared minus 3 over x minus 1. So let's expand that numerator. We could factor out a 3, right? And then what's left over might look familiar. X squared minus 1 is a difference of 2 squares. So we can factor further. We can now say, okay, that's x plus 1, x minus 1. And the denominator is x minus 1. So we can almost cancel x minus 1 over x minus 1. And that would be fine, except the remaining function, although it would be exactly the same as the original, it would be defined at x equals 1, which this function is not, because it makes the denominator 0. So we have to note that restriction. So this becomes 3 times x plus 1, except x cannot equal 1. But what this tells us is that if we were to plug in x equals 1 into this, we would get k. So now that we've eliminated the x minus 1, we can make that substitution. So I'll write that here, let x equal 1, then that becomes 3 times 1 plus 1 is 3 times 2, which is 6. So k equals 6 is going to be the value that does it. If this algebra was a little kind of hard to follow, it might not be a bad idea to do a graph. What this function actually ends up looking like, this function is exactly the same as this function, except for the fact that this function's domain is defined everywhere. X can be any real number. Whereas this function is defined everywhere except at x equals 1, which is why when we wrote this, we had to note that restriction, that x could not equal 1. But what is this graph? It's actually just a line, right? It's y equals 3x plus 3. So if you were doing a little sketch, you'd get y-intercept of 3 and then a slope of 3. So it's a pretty steep line. Maybe it looks something like that. And that's the graph, y equals 3x plus 3. And that's where it's defined everywhere, but the original graph is not defined for x equals 1. So there's some point up here where there would be a hole or a removable discontinuity in the graph. And that's where they use this piecewise function to say, okay, let's define k as being the y-coordinate of the graph when x equals 1. That way we'll make it continuous by defining it at that point, even though it would otherwise be undefined. Hopefully that makes some sense and helps.
Hi, thanks for watching. If anything's still confusing or you need a little extra help, drop me an email, leave a comment, or give me a call. I answer every message. And if you want to check out more videos like this, visit wewillteachyoumath.com. See you in the next video.